Good day, everyone. Today we're going to be talking about our third method within the lesson 3-1, which is going to be solving a system using elimination. Okay. So far, we've already talked about graphing and substitution. This will be our last given method using elimination to solve it out. Before we actually get into the final step, which is going to be the word problems of this lesson. Okay. So bear with me. Should be only a couple minutes long. We're going to go through on how to solve two problems using the elimination method and kind of talking about how we actually use it, how it's applied, and things like that. Okay. So just so you know, in your book, there is an example of this. If you'd like to look at this, on page 34, there is an example of using the elimination method. We will go through a couple of problems together, particularly A and B. We're going to cover each of these and how to actually solve it, what's our actual goal. And then once we're done with each of these, okay, I'll kind of let you off to work on some of the questions in the Ed puzzle and go from there. So let's just talk about in general what we're dealing with, okay? We talked about it the other day with substitution in that in this type of problem, it is an elimination method, okay? We're given a system of equations as we see up here where we're given two different values, one here, where we have a y and an x both equal to one another, okay? Within this problem, what we need to do now is be able to solve for both x and y. So just so I kind of know this, I want to figure out what x is equal to, what y is equal to. Okay, that is my end goal. To do this, we've already talked about a couple different methods, and today we're going to talk about the elimination method. Okay? So let's just talk about what we want. For elimination method, we want two values, one from the top equation, one from the bottom equation, in which they have the same value, so same number, with opposite signs. So if you notice in this first one, obviously the first one's going to be fairly easy. The top value has a negative 3y. The bottom value has a positive 3y. This is going to be our goal for every one of these problems. Always try to get values with the same number, opposite signs. Okay? Now, in a lot of problems, we're going to have to try to adjust it to actually make it work for us. But for this one, it actually works out. So here's all we're going to do. For elimination method, now that we have negative 3y and positive 3y, we are going to add these two equations together. And you'll kind of see why it's called the elimination at this step here. Negative 2x minus 5x would be negative 7x. Negative 3y plus 3y will actually cancel itself out. Negative 3 plus 3 is going to be 0. So they're going to eliminate each other. Then on the right-hand side here, we have 5 plus negative 40, which is negative 35. Once we take that step, all we have left now is this equation, negative 7x equals negative 35, which, easy enough, we can go ahead and solve out for x in this one. We divide out negative 7 to get x equals a positive 5 as an answer. Okay? So at this point, I just want to find the y value. And there's not really any math or anything extra I have to do. I just want to take the value I had, which is this 5, and just plug it into either of these equations up here. So let's go ahead and use the top one. This would be negative 2 times 5 minus 3y is going to equal 5. Well, we go ahead and work this out. This comes out to be negative 10 minus 3y equals 5. We're going to add the 10 to the other side. Negative 3y equals 15. And last but not least, we divide out that negative 3 to get y equals negative 5. And just like that, we came up with x and y. Okay? Now, the key difference between this method and the other methods is the fact that we're strictly trying to eliminate a variable at the beginning of this. So when I go back to this portion right here, notice how my goal is to get this situation, a positive and negative value, each with the same number. Once I do that, I can just add them together, and then they will naturally cancel themselves out, and I'm given one of the two answers. Okay? Now, the kind of key thing with this problem is that we need to understand that not every time we're going to get situations as perfect as this was. Okay? A lot of times we're going to have to adjust the problem to actually make it work for ourselves. So let's go ahead and talk about one where we actually have to adjust it. In letter B, we're given 5x plus 6y equals negative 14 on top, x minus 2y equals 10 on bottom. And our ultimate goal is, once again, to try to get two values that are the same number with opposite signs. Okay? So I got to look at this problem here and try to think. I'm not given that right off the bat, so I need to adjust it. Well, what I want to do is I want to focus on the y's here. We have a 6y and a 2y. What I want to say is, how do I make the bottom 2y into a negative 6y so that they are opposites on the top and bottom? Well, I can do this by taking the bottom equation and just multiplying by 3. Now, if I rewrite the system, this is going to be 5x plus 6y equals negative 14 on top. That one doesn't change. And then if I multiply the 3 to everything in that bottom equation, this becomes 3x minus 6y equals 30. Now, if you notice, look what happened to my y's in my new equation. By multiplying by 3, I have two values, each with the same number with opposite signs. At this point, I can take that step again and add them together. This becomes 8x. These two would cancel, and that's going to be equal to 16. Or in other words, after we divide out the 8, x equals 2. Okay? So in this type of problem, what we need to do is we need to adjust our actual equation. Now, this is really kind of an easy step though, right? Because we just have to think, how do I make a 2 into a 6? Well, we do that fairly easy just by multiplying by 3. The only thing we can't forget is that this 3 gets multiplied to everything in that equation, not just the 2y. Okay? To finish off my last step, I'm going to take that equals 2 and plug it into the equation. I'll go ahead and use the bottom one. So I'll use this original bottom one here. X minus 2y equals 10. We know x is equal to 2, so we have 2 minus 2y equals 10. Subtract the 2 over because it's already a positive. 2y equals 8. And then divide out negative 2 to get y equals negative 4. And once again, we have our two answers. Okay? This is essentially the elimination method. Okay? While substitution, we were plugging a whole equation into a value. In the elimination method, we're actually canceling values out. Okay, so our goal ultimately is going to be, how can I make two values similar with opposite signs and then basically cancel each other out by adding them together. Okay. Go ahead and answer the last question on the Ed puzzle. If you have any questions, bring them to class tomorrow. And besides that, have a great day.